8th grade lesson 10.3 is similar figures. This is kind of the same idea that we did a few lessons ago, where you had to kind of figure out what transformations happened to get from one place to the other. Similar to that, only now we're including in those transformations the dilations. So I'm going to go over a quick review of the algebraic representations of those transformations. I'll draw them out and then go over them with you. Okay, we had that, there's those pages with all those rules on it. I've tried to summarize them all in one place just to dust off our cobwebs. If I have a translation, I'm going to see my x and y coordinate having something added if onto the x coordinate. If it's for side to side, if it's added to the x coordinate, it's going to the right. If it's a negative to the x coordinate, it's going to the left, or subtracted from the x coordinate, it's going to the left. Up or down movement will be added to the y coordinate or subtracted from the y coordinate, up for add and down for subtract. If you have a reflection and it's a reflection across the x-axis, then you do the opposite of y on your coordinates. If it's a reflection across the y-axis, then you're doing the opposite of x, multiplied by -1, right? If you have rotation, 90 degrees clockwise, you do the opposite of x and swap their orders. X becomes y, y becomes x. 90 degrees counterclockwise, opposite of y, and then swap. 180 degrees, opposite of both, and then swap. And then dilations, you're just multiplying both by their scale factor. If it's a whole number, it will be bigger. If it's a fraction, it will be smaller. So there's a brief little rundown of all of the transformations we've looked at. Okay, so with those in mind, and I've translated them over to this page too, you in this lesson will see either a set of steps they want you to do to get to a final product, a final image, or you might see images that already happened and you have to say what happened, just like you did in a previous lesson. But now they, like I said, they include dilations. So let's look at what happens if they give us a pre-image and they say, oh, do each of these things to it. So I'm going to look at A, and I notice they've added some to X and minus some from Y. This is a translation where you're adding things to X or subtracting things from Y, and I'm going to the right 7, positive 7 direction, and I'm going in -2 direction. So I know that this is a translation. I can algebraically do it, or I can just count. So I've made a translation here, and I'm just going to take, I know it's going to go 7 to the right and 2 down on each of my points. So I'm just going to do that. 1, 2, 3, 4, 5, 6, 7, 1, 2, and mark it. And then again, 1, 2, 3, 4, 5, 6, 7, 1, 2, and mark it. Then from this vertices, 1, 2, 3, 4, 5, 6, 7, 1, 2, and mark it. And the final point over 7 down 2, you can kind of see where that's going to go to. And that is step A. Now I'll look at what they want me to do for step B. They want me to do the opposite of y, So it looks like I'm going to end up with a reflection across the x-axis. So I could either do that algebraically, or I could recognize, okay, here's my x-axis. This rule forces a reflection across the x-axis. So I can just do that. 1, 2, 3, 4 away there. 1, 2, 3, 4 away there. 2 more, 2 more. There's my reflection across the y-axis. Now they want me to rotate 90 degrees clockwise around the origin. Okay, you guys know I'm going algebraic on this one. I am not going to try and do this visually. 90-degree clockwise around the origin. So I'm going to do the opposite of all my x points and then swap their order. So I'm going to gather from this point all of my coordinates. I'm going to list them over here, and then I will do that magic, opposite of x, and swap. Okay, there are my coordinates for that B, this one here. These are my coordinates for all my vertices. Opposite of x, so 5 will become, opposite of x. So 5 will become -5, and I'll swap their order. So I'm going to get, I want to do that in a different color. Hold on just a moment. Let's do this color. 5 will be negative 5, and I'm going to swap their order. So negative 4, negative 5. 5 will be negative 5. I'm going to swap their order. 1 will be negative 1, but I'm going to swap their order. And 1 will be negative 1, but I'm going to swap their order. And then I will graph those 4 points. Okay, and there is my rotation, clockwise, 90 degree. The next thing they want me to do is they're again adding to x and adding to y. When we're adding or taking away from x or y, we have another translation going on. I'll go ahead and use that same color as before. We're translating. They're positive, so we're going positive direction to the right on the x, so 5 that way, and 3 up. So from each point, I will go 1, 2, 3, 4, 5, and 1, 2, 3 up, and mark it. And from this one, 1, 2, 3, 4, 5, and 1, 2, 3 up, and mark it. Okay, and I did all the rest of the points that way. Then I go on to step E. This, you notice, I'm multiplying both the x and the y by a scale factor of 3, so we should be seeing a dilation. I'm going to go ahead and record my coordinates down here and do the multiplication. Okay, there's my coordinates. Now I will multiply them by that scale factor of 3, like they said. This will be 3, 6. This will be negative 3, 6. This will be negative 3, negative 6. And this will be 3, negative 6. I will mark those points. 3 on the x, 6 on the y there. Negative 3 on the x, 6 on the y there. Negative 3 on the x, negative 6 on the y there. And 3 on the x and negative 6 on the y there. And that is my enlargement. List the points. Okay, good thing I wrote them down. 3, 6, negative 3, 6, negative 3, negative 6, and 3, negative 6. Look at the shapes of all of these. Has the shape changed, or are they all the same shape? They're all rectangles, right? So they're all rectangles. Same shape. Rectangles. What about the size? Are they all the same size? Most of them, right? But except when we enlarged. So we can say no, they're not the same size, or we can say all are the same size except the enlargement. When we did the dilation to it, that changed the size. Check out our angle measures. These are all 90-degree angles, 90-degree angles, 90-degree angles. All of our angle measures stayed the same, no matter whether we dilated or not, right? All the same. 90 degrees on all of those. And so that's part of this lesson is, what is happening? What, make these happen. Not what is happening, I guess I should say. Make these transformations happen. And this is helpful to have handy to do that with. The other thing they might ask you to do is, that's not straight, let's straighten that, is determine, okay, well, how did I get from one image to the other? How did I get from pre-image C to image D? What happened? So just like we did previously, you're going to just kind of observe it and do the same thing. Well, first thing I notice is they're facing opposite directions, so I must have had a reflection across the y-axis. So reflection across y to flip that around, right? So now I've gotten, if I reflect this across the y, now I'll have it facing the same direction. You can see that this one's smaller, so we have a dilation that cuts it, looks like in half, because I have 4 there and 2 there. So I have a dilation of 1/2 to shrink it. So I multiply those by 1/2 to make it smaller. So now I have it over here facing the other direction, the way I need it to, and I have it smaller. Now I just have to move it, and that would be a translation. I don't go side to side though, I just go straight up. So translate and it would be y plus, let's see, if I shrunk this down by half, I'm going to get to here. So that's going to end up over here. That is up 1, 2, 3, 4, 5. So plus 5y plus 5. So those were the steps that would have to be taken in order to convert this into that. And so that's the only other part of the lesson is how did I get from here to here, much like you did before, but now we also have to recognize those dilations that happen. So that's it. That's the lesson. Good luck.